You're already familiar with the idea of casting because you've seen that in the context of casting primitives from one to another. It turns out that that principle of casting applies equally well in the context of objects. If you recall our method M that was introduced earlier, it required as a parameter type an object of class object. And yet, we're allowed to just put in as an argument for it new student, as you see in that first line of code near the middle of the slide. Why does that work when we're passing a student, but a student, even though it's completely true that a student is an object, M is asked for an object. So how does this mechanism work? Well, it turns out that there's some implicit casting going on here. The statement that you see there is equivalent to the statements that are at the bottom of the slide. The difference, of course, is that when we say M new student in brackets, the student object is anonymous. It doesn't have a name, whereas in the version of this down below, we actually give it a name O. But more importantly, the declared type for O is actually going to be different than the actual type for O. The actual type for O is student, but the declared type is object. Now, since the actual type is student, then in the second line of code where we say MO, we're actually passing a student, or it looks like we are, but implicitly what happens is that it is cast to an object. And this happens simply because student is automatically an instance of an object because of the inheritance relation, because of the is-a relationship. A student is an object. So although we haven't actually used a cast, implicitly a cast does exist here. In this next example, implicit casting isn't going to do the job for us. It won't work and we will get an error. If you go through the lines of code in this example at the top of the slide, you'll see that we have an object O whose declared type is object, but whose actual type is student. Now, you would think that it is clear that object O is a student object. So you would think you should be able to, in the next line of code, say declare a object B of class student and set it equal to O. But the compiler is not quite clever enough to figure out what you're trying to do here. And it's going to look at this and say, well, wait a second, O has been declared to be an object. I can't set a student equal to an object. Although it's perfectly true that all students are objects, not all objects are students. And that's why we can't assume that this line of code will work, because we're trying to set a student equal to an object. However, in this case, this particular object, O, happens to be a student, and therefore it would be perfectly legal and acceptable for us to go ahead and cast it. But we'd have to use the cast operator explicitly. It's not going to happen all by itself implicitly like in the previous example on the previous slide. So we would have to actually put the cast in, and you can see that happening at the bottom of the slide here. We have the cast operator, that's the pair of parentheses with a type or class name in it, and the class name is student. And by putting that in front of O, we're telling the compiler that we mean for it to treat O like a student. And when we do that, then of course it's perfectly legal for us to say student B equals student O. You don't need to use explicit casting when you're going from a subclass to a superclass, because anything in the subclass is an instance of whatever's in the superclass. And that's where we saw implicit casting would be used instead. But when you're going the other way, you do need a subclass. And that's what we saw as an example in the previous slide, where if we didn't explicitly cast, we got an error. You might think that you can then go ahead and cast whatever you like to whatever else you like, but you can't. And in fact, it has to be the case that the superclass must actually be an instance of the subclass. If it's not, a runtime error will occur. So we see that happening in the example at the bottom of this slide. Here we have an object O of declared type object and actual type person. It is a person. It's also an object, but it certainly isn't a student. So we can't just arbitrarily cast it to look like a student. So we wanted to set student B equal to O. We can't merely put a student cast in front, because O is an object and it is a person as well, so we could cast it as a person, but it's not a student. and that's why we're not allowed to cast it as a student, and we will get an error in this case if we attempt to do that.